Hello everybody, welcome back to Cement Manufacturing Practice Series, fourth episode on Chemical Industries Engineers channel. The second step in cement manufacturing after crushing is grinding or milling. The most used mills in cement industry are vertical roller mill, ball mill, roller press, and Horo mill. The difference between these types is efficiency and power consumption. For the materials to be grinded, there is an important factor, its grindability. The grindability of the material is determined by index like hard growth index and Bond's-work index, where hard growth can be determined by the following equation, where D is the fraction of 50 grams of coal with size between 0.6 to 1.18 millimeter milled by the mill by 60 rounds through pass 74 micrometer with 200 meshes, while Bond's work index related to hard growth index by the next equation. As we mentioned in the last episode, drying done in the mills, but in coal mills should be caution of using hot air to avoid firing of coal. So, to protect our process, inert gas is used. Almost 60 to 80% of electrical power consumption for grinding step. Now, let me talk about types of mills, and let me start with ball mills. It's a cylinder rotating around its axis and partially filled with balls. It's used to grind and blend raw materials, coal, or clinker with additives to form cement. In wet process, raw materials grinding by ball mills is preferred because we should add about 36% of water to the raw materials to produce raw thick slurry, and other types of mills couldn't handle with this slurry. But in either dry or wet process, ball mill is the most common type used to grind and blend clinker with its additives. In this type of mills, two ways used to separate fine and coarse products, by air swept or by bucket elevator. By air swept, where the air passes through the mill and take the fine to the separator and leave the coarse to regrinding. In this case, drying done by passing of hot gases through drying chamber or external drying drum. Whereby bucket elevator, where the products taken by conveyors to the separator to take the fine to the next step and return the coarse to regrinding. In this case, drying is done in the mill or the separator by hot gases. For high efficiency separators, drying done in the mill. About grinding media, there are 3 to 4 different sizes of balls are used, with different proportions, and the cylinder filled with 27 to 35% with grinding media, and the sizes are distributed in chambers, larger balls in early chambers. Grinding media, which used now, made of high chrome steel. And about the shell, it's fitted with liners which made of high chrome liners or manganese steel. The design of lining has high effect on efficiency of the mill. The last component in ball mill is diaphragm. Now double diaphragm system is used with flow control, where intermediate diaphragm used to control the size of the raw materials flow from chamber to another, and final diaphragm control the size of the products of the mill. where the diaphragm is punctured with specific dimensions to allow the required volume to pass through it, and its end is wider than its beginning to avoid accumulation. The second type is vertical mill. Principle operating of vertical mill: two, three, or four rulers rotating around its axis, and the press on rotating table. In general, the rulers it's all in the same size, but there are some designs use rulers with different sizes. The feed enter at center of the table and pass to the surrounding of table by centrifugal force of the rotating table to grind by rulers. And then the gas is drawn from the bottom of the mill by a fan and take the products to the separator, where fine products go to the cyclone and then go to the silos, and coarse products back to the mill to regrinding, while the residual pass by scrubber to the refeeding. The rulers and table are lined with replaceable liners made of manganese steel. Feeding size of vertical mill about 5% of the ruler's diameter. If the feeding is too dry, vertical mill will expose to vibration, and to avoid this, spray water is used inside the mill. And if silica content is high, wear rate of vertical mill will increase. And about the separators, in a new vertical mill, high efficiency separator used in order to reduce the power consumption. The vertical mill consumes power less than the ball mill by about 30%. And the vertical mill it's often used for coal and raw materials grinding. The third type it's ruler press. It works by using two rulers. The two rulers using pressure force between them to reduce the size of the feed, and the products become like a cake. The distance between the rulers affects the fineness of the products. After milling, the products go to classifier. Often, the parts pressed by the edge of the rulers coarser than the middle parts. So, the coarser parts back to repress, or in some cases, where ruler press used in sequence with ball mill, the products go to the ball mill without classifier, and then go to high efficiency separator. This system it's not common for raw materials and coal grinding, but it's often used for clinker grinding. The advantage of the roller press it has low power consumption, but the disadvantage it has low productivity and high wear rate. The last type it's Horo mill. It's combination of ball and roller mills. It has cylindrical shell turning around its axis, and inside it turning ruler instead of balls. This type consumes power less than ball mills by about 30%, and it can drying the feeding to about 20%. In addition to it has low wear rate and needs area to install less than the ball mill, but its efficiency affected by grindability of the materials. I hope this video is useful, and if you work as a chemical engineer in cement factory and interested to share your knowledge and experience with other engineers, please feel free to contact me at any time at my LinkedIn account. And don't forget, to like, subscribe, and share the video. Thank you.